So I'm very excited to introduce our last three panelists talking about career paths outside of academia. And this was actually a question that came up in the very beginning of today about talking with advisors about pursuing non-academic career paths and about the role of getting a PhD in pursuing a non-academic career path. So these are the three experts at navigating this. So our first panelist is Analui, and I should have verified pronouncing his last name before this. Then Taylor Lenton, and then Ward Lopes. And I will let them give brief backgrounds. Benham.
Thank you, Andrea, and hello, everybody. Thank you for having me. So I was instructed to give a 5-minute brief, so please stop me if I'm going over, because I have a lot to talk about. So let me just give a quick introduction of my background. I received my PhD in 2006 from Caltech in electrical engineering. Then I joined a startup in San Diego, a startup, and this is 2006, and that startup was acquired last year for $700 million. Yay! And then I came back to academia, believe it or not, and joined USC as a research scholar for 5 years. So I have been on both sides of the aisle. And I think Ward has the same experience, so I'm sure she's going to share more with us too. I was a lecturer at Caltech, and then I decided, well, I have to go back to industry. So for the past 5 years since I left USC, I have been an entrepreneur. So, and this is where I want to create this distinction. I don't agree with the forking of academia versus industry. I think there's a third category. Maybe in the category of industry, we should divide it into industry, big corporation, private sector versus entrepreneurship. So we'll talk about it more, and I'll tell you what my beliefs and positions are on that. So in the past 5 years, that's what I've been. I've been an entrepreneur. I've started one company that got acquired last year. I'm now started the second one that I'm working on right now. I'm also coaching two other founders, two other CEOs who have their own company, and it's a lot of fun. On the topic, I'll just briefly mention what is my position, and then we can go into the questions, Andrea, from you or the audience. Should we pursue a PhD, whether we want to go to academia or become an entrepreneur or go to industry? My position is absolute yes. It doesn't matter what you want to do. My personal experience is, what I did and learned during my PhD has been a great guide into, different levels of success and achievements that I've had. One thing I want to add to that is I see PhD as really giving me two things. One is knowledge and one is process. And depending on whether you want to do, let's say, become a professor, go to academia, or be an entrepreneur, I think you would leverage, or I leveraged, different degrees of these two independently. So, for instance, when I become an entrepreneur, I would say not necessarily the knowledge that I gained in my PhD was very helpful to me, but the process of going through a PhD program was absolutely essential to get me where I am right now. So I'll stop there, and then we can continue at the wedding.
So Taylor?
Hi, everybody. My name is Taylor Lenton, and I have a PhD also from Caltech in chemistry. And I think I'm a little bit different from some of the other panelists on this because I've gone a little bit even farther beyond just industry necessarily. So I moved into industry very briefly right after my PhD, and I was working at Intel and spent about 1.5 years there doing some basic research in process engineering, and then kind of decided that even that was not exactly where I wanted to be. So most of my postgraduate experience has actually been in forecasting and data analytics, which is much more on the business side of the world than on the science side of the world. But I would absolutely echo what Benham just said. For me, the PhD, well, first of all, I've always worked in companies that have a very large basis in science. So I'm currently working at Amgen, which is a biotech company. And so that's always been important, and having that science background in itself has always really helped me understand the products and understand what we're trying to do. But in my current role, I lead a team that does market research, so we do surveys, and we do data analytics to understand a market of products that are actually currently out there. So they're not being developed, they've already been approved by the FDA, they're already being prescribed by doctors. And so the work that my team does is to really understand the business side of it and the market side of it, which at first glance may seem very unrelated to where a PhD could help you at all. However, what I found is that the process of going through that PhD is really one about learning how to be very comfortable with uncertainty, learning how to be able to take 2 or 3 different paths, the first step, and see which one is the most promising, and being able to kind of pursue that further. And that's exactly the situation that I find myself in every single day. And so it's really allowed me to be able to come up with new ideas and pursue things and feel very comfortable in that space still, and be able to then provide a lot of value. So I will say also that even though it feels like I'm kind of outside of the realm of science at this point, I work with probably about 1/3 of the people that I work with right now have PhDs in the sciences. So it's not an unheard of path to, once you're done with your PhD, to kind of realize that maybe there are things other than just the absolute basic research that interest you. Most of the people that I'm working with PhDs actually went into consulting companies right after their PhD. So that's definitely a path that people take. Places like McKinsey, LEK, they come and recruit at USC and at Caltech and all of these other schools. I went a slightly different path because I did go into industry very briefly before deciding that I wanted to move on to the business side. But there are, I'd say, multiple areas, like Benham said, entrepreneurs, very large company industries. I know people have gone into the patent law side of things, the consulting side of things. And all of these people that I know who've done these PhDs have really excelled in those fields because they know how to learn, they know how to dig into a topic, they know how to communicate out what they're doing in a way that can appeal to a broad audience.
Ward, you're up.
Okay. So yeah, I'm Ward. And I would say that I've spent a lot of my career sort of crossing back and forth over the line, like Benham said, between academia and industry. So, I was an undergrad at Swarthmore College, got a physics degree and did some research there. And then I went and did a PhD in soft condensed matter experiment at the University of Chicago. And while I was there, I was lucky enough to get involved with some internship-like experiences where I did some consulting for Dow Chemical and then for a law firm on an IP issue. And then immediately after grad school, because I was interested in, how does new technology and new knowledge come from the lab and get made into products, I joined a startup called Eric's that created scientific equipment, sort of holographic optical trapping, if you know what that is. And after a couple of years, that turned out to not really work out for me. So I went back and did a postdoc at the University of Chicago. Then I did faculty positions at Mount Holyoke College and Williams College. And while I was at Williams, I found that I really missed having my hands sort of deep into research instead of doing research through my students. And I also found out that my favorite part about writing grants was having them written. Grading was never a joy. So I decided that it would sort of be easier to find a position in research in industry where I was able to do the kind of work that I wanted to do, and somebody would support that and take care of the sort of financial part for me and allow me to put my hands sort of deep into the research. And so that's when I transferred to NVIDIA. And I would say it's sort of my sort of grand thought about whether you want to choose industry versus academia has more to do with what kind of work you'd like to do. And what you should try to do is try to find and figure out what is the kind of work you would like to do, and then find some entity that will support that. Or if you're an entrepreneur, create the entity that will support that, right? And then just go for it, right? And a PhD was useful for me because it was a great calling card. Because I like my independence and being able to choose the topics that I work on. Having a PhD meant that it was assumed that I could do that.
So that kind of leads us into our first question. For the industry panelists, was there anything that you wish you knew during your PhD studies, and what can graduate students starting or early in their programs do to better prepare for a career in the private sector? And they added a thank you very much.
I can take this.
I just wanted to convey that. Yeah.
So what I would say is, when I was doing my PhD, one of the things I really wished I knew better or more was the importance of interaction with the industry. So the opportunity was always there, and I'll give you an example. Two examples that come to mind. One is internships, and one is attending, conferences, symposiums, workshops as a PhD student. Obviously, there are a lot of opportunities. Companies love interns because they're low cost and they're very smart, and they do a lot of work. But as a PhD student, I was very naive, especially in the case of conferences at the time. I remember we had this annual pilgrimage with the whole research group to one of our most prestigious conferences in San Francisco, always in San Francisco. But we would plan to use it as a social event with the rest of the research group members rather than actually taking advantage of what's going on as the latest and greatest problems that exist in our field, and what are the next 5 key problems to be aware of and work on. So interactions with industry, both the people in the industry as well as general trends in the industries, is what I wish I would have known the benefits more and had taken the advantage that existed for students. There's always lower cost fees. There's always, as I said, companies looking for interns, and I would recommend anybody who is thinking of joining a PhD program to be aware of those and take advantage of those.
Ward?
Yeah, I would have said, I guess I've been thinking about that. I was really lucky to have the sort of internship interface and to be introduced to some of the differences between industry and academia. I think, though, the one thing that I wish I'd known more about were more soft skills, like networking. It sort of dovetails with the previous response, which was, just going out and meeting a bunch of people who are not in your immediate group, and finding out what they do, first of all, just because it's interesting. And then second of all, that just sort of sets you up for the next stage. I think that, when you're in academia, you're used to the way that you find a job or the way that you find the next thing is you go through the application process for the next step. And I have never found one of my jobs that way. It has always been through sort of essentially plumbing my network. And I wish that I had sort of built that up more when I was in grad school.
Taylor?
Yeah, I agree with the others. I do wish that I had known that many of the largest companies across industries do have summer programs for PhD students to come in and do internships. And I also wish that maybe I had realized that that was a good use of my time as well, because I feel like for many people in the middle of their PhD, you're so focused on getting your research done. That's the only goal, right? How do I get out of this PhD program? Whereas taking the time, like others were saying, to network, to learn and meet people within industry, other people around your school who are doing totally different things than you are, is a really valuable way to enhance the education that you're getting in the lab. And so I think that having done more of that would have been really valuable. And then I also really liked what Ward said about the networking piece of it. I think that one of the biggest differences between industry and academia is kind of the pace and the manner in which you network or which you have meetings and meet people. It's a very different type of environment. There's a lot of, I'd say the meeting structure is very different. The kind of cadence that decisions are made in I've found to be very different. So having a little bit of that experience, or even just speaking more regularly with people who have graduated and moved on and gone into industry, right? I felt like a lot of times people left, they got these great jobs, and maybe you kept in touch socially, but you didn't really dig in and say, well, what's it really like working in industry? So even all of those just very little things that you can do that aren't an official program would really help.
May I add something to that, Andrea? So this is something new that wasn't available during our time, but one thing I've noticed, for instance, that Caltech has started, and I'm pretty sure many other PhD programs have already or will add, is mentors. So these are individual mentors who are, gone through a PhD program or in industry or even at academia, and they schools and PhD programs have actually created this network, so students can have those one-on-one interactions while they're in program, and ask these kind of questions that some of our audience is asking right now. So take advantage of those as well.
And that's also something, if you're applying to a PhD program, to ask if the school has this type of mentoring program in place. So there's a question about research in industry versus at a university, and how to consider choosing. So what's the difference between research at a university and research in industry? And I think this kind of touches on a comment Ward made about either leading the research group and writing a lot of grants versus in industry, maybe it's more hands-on and somebody else, namely the company, is worried more about the money. But then also a comment that Benom made earlier, talking about the difference between a small industry versus a large industry, also, a small company that you yourself started, so kind of redefining what industry means perhaps in smaller increments. So I'll let Benom start so he can initiate the conversation and kind of redefine industry in smaller terms.
Absolutely. So I think that solving a science or engineering problem will always exist, even if you're talking about a really small company that just started. Let me give you an example of the one that I'm involved right now. So I'm one of the companies that I'm coaching the CEO. It's a technology company out of Caltech. And as we have over the past 2 years developed the technology that was licensed out of Caltech, we have realized through our interactions with customers for the future that there are still some problems that needs to be solved. And more specifically, for instance, this is a power technology company, but the power that they're delivering needs to be more efficient to the devices. So that's kind of a deep fundamental problem that this company is now facing. And as part of that activity, we have to start interacting with other potential industry partners and try to find real engineering solution into, for instance, coming up with a new semiconductor device that can make this power transfer more efficient. So in terms of nature, the type of problems and problem solvings that should occur, I would say, that I have dealt with in my experience, they're very similar. You have to solve an engineering or a scientific problem. I would say the approaches might be a little different in that there are some other parameters that might be less important in academia come into place. For instance, timing might be of importance. How long does it take to solve this problem, and should you even think about it if it's going to take 2 years or 2.5 years? And the other could be budgetary and economics of solving the research problem. So the process of making a decision about whether at all going through a specific research problem or not in the industry might be different. But the natures are very similar. One other thing I will add is especially in technology companies in the industry, so not talking about, for instance, management consulting companies, but technology companies, semiconductor companies that I've worked at. When a PhD student comes in as an intern, they are actually solving real research problems in an industry. And, for instance, me, myself, as an intern, 2 or 3 of my patents are based on the research problems that we solved when I was interning at IBM Europe. So depending on your industry and the type of problems, it could be very similar to the type of research you'll do.
Taylor?
Yeah, so in my experience, it has depended a lot on what stage of the process development that you're in and the pipeline that you're in. So at Intel, I was in a rotation program where I got to spend 6 months doing 3 different types of roles. And the way that I structured it was actually to do one on the very basic research group, one that was more in process development, and one that was actually in kind of the more manufacturing side of things. And each of those roles are very scientific, but they all have a very different type of focus, and some were much more similar to academia, and some were quite different. So I would say that on the very basic research side, if you have a small group, and some startups may be like this, there are normally at least some groups within large companies that are really devoted to the kind of exploratory analysis that you find a lot in academia. So there will be a big picture goal that you're working towards, a potential drug target or some new advance in technology. But the expectation is that those still may be 5, 10, 15 years out. And so the types of questions that you're answering, the type of research that you're doing is still very similar to the kinds of things that you're doing in the lab. Then when you move into something that's a little bit more process development, you probably have a target in mind. You might have a substrate that is most of the way there. You might have a piece of equipment that is working in proof of concept, but you need to scale it up somehow. And these are very different types of questions. They're still day in, day out looking at what is the goal that I need to get to make this project work? Where is the chemistry maybe failing? Where is it working? What can we do to fix it? And I think that's where you see a lot more of these kind of economic and time constraints come into play that you might not have always had in your academic setting, because at the end of the day, if this product is going to work or come out, you might need to take the second best solution because that's the one that you can source and you can find a workaround. Maybe there's a defect in 10% of the material when you do it this way, which isn't perfect, but it works and you've validated that it can work, and so you can move on. So to me, those were very different types of settings from what I was used to in academia. And then once you move on to the kind of more full manufacturing side, I'd say that's the most far removed from the kind of academic life because the process is set and your job is to make sure that you fully understand all of the chemistry going involved into that process, and that if anything starts to deviate, you need to problem solve, but it's much more of a problem solving mode than it is a exploratory and research mode. So I think that there are different types of jobs within academia that fit lots of different types of personalities, and some of them are a little bit closer to the traditional academic research I did as a PhD student, and some of them were a little bit farther away.
So just to sort of build on Taylor's answer, I think that at NVIDIA and other places that I've been at, like the main difference between the 2 types of research has been sort of the fundamental question of what's considered the fundamental question, and the sort of you're doing this and then so what. And in academia, like the best fundamental question you could answer is, how is this going to fundamentally change my conception of this broad area of knowledge? And at NVIDIA, the fundamental question is like, okay, let's suppose that you are wildly successful and it all works out. Like, how big of a difference is that going to make for NVIDIA, right? And so it's sort of, in one sense, the purse strings are held on one end by, funding agencies in academia who are interested in sort of general knowledge, and then in industry, it's like, we're paying you to help this company, and so we're willing to support anything you want to do, as long as you can tell me how this is going to, in my case, sell more GPUs, right? As opposed to sell more drugs in other places, right? But I would say that the kinds of questions, like the way that Taylor broke down her answers about the drug industry, pretty much mirror what happens at NVIDIA, right? There are questions that you ask if you think that you are 5 to 10 years out, there are certain sort of things that NVIDIA is willing to support for that kind of research. But those questions are very different for something that's 6 months out.
So there are two questions that are very similar. So are there differences in job opportunities, like the number of open positions after doing a PhD versus doing a master's? And then kind of a related question, how does a career trajectory change if you have a master's versus a PhD? Right, so one is getting your foot in the door, and the other is how your career launches after you have your starting position. So why don't we start with Taylor? Because, I'll put her on the spot.
Yeah, exactly. I think this is it's a difficult question to answer. I think it depends a lot on the specific industry and the specific PhD that you have. I do know of many people that were kind of in my graduate cohort who had engineering degrees that stopped with masters, and that was a really good choice for them. I think in particular in the field of chemistry that I was in, the master's was not seen as often as a place that was easy to get jobs, whereas the PhD was a little bit more of a natural stepping stone that most people took to get into industry. But I definitely wouldn't want to make a blanket statement about that because it varies so widely across the type of job that you want, across the type of degree that you're getting, that I would definitely say talk to the people at the university you're considering, talk to the people who are looking more at the specific path that you're thinking about and try to get a more specific answer for that. In terms of once you're in the door, I have found that getting that first job out of school, regardless of whether you're at a BA level, a master's level, a PhD level, seems to be the most difficult. There are a lot of people, they all graduate at the same time of the year, pretty much. PhDs are spread out a little bit, excuse me, but there's still kind of an influx of people steadily looking for jobs all at the same time. And I think that it can be a little bit discouraging, but most people, as you kind of keep at it, find something. And I would say that for many people that I know, myself included, the job that I first got out of my graduate program was not necessarily the job that I'd always envisioned in my life. It was the one that was available to me at the time. So when I first was getting ready to graduate, I actually had two different offers that were like 90% going to come through. One of them was a postdoc at a national lab, and one of them was the job that I took at Intel. But it turns out that the government shut down 3 times that year. And so the postdoc kept getting postponed and kept getting postponed. And I finally said, you know what, there's a lot of interesting stuff in this industry position, and it's a sure thing, and I'm gonna try it. So my experience has been, since getting in the door, those next jobs have been easier and easier, and it's been up to me to direct my career at that point. So to the earlier discussion about networking, absolutely agree. I have not gotten a lot of jobs or any of my positions through application going into a portal and somebody seeing it and saying, oh yes, you're the exact person that we want on paper. But by talking to people throughout the companies that I've worked in, at companies that I have friends at, I've gotten to learn more about the types of roles that I might be interested in and kind of say, hey, this might be something that I want to do in a couple years. Can you tell me a little bit more about it? What are the skills that I need to develop in my current role to make this a possibility? At some point, maybe getting in touch with a manager and saying, if I were to ever work in your group, what's the kind of thing that you would be looking for? So all of these are much softer skills, and I think that regardless of whether or not you have a master's or a PhD, as long as you're proving yourself, as long as you're working hard, producing results, and have kind of all these soft skills to go along with it, I think that the sky's the limit. It might take a little bit of a different pathway depending on exactly where you start, but I don't really see that there's the PhD is the only thing that can get you here, unless you're looking for that traditional academic career, but that's not what this panel is all about.
Venom?
So I will answer it from 2 different perspectives. One is from the perspective of if I want to hire somebody, I look at the fact that they have a PhD or they have a master's, and the answer to that is not necessarily. If you had decided to go through a PhD program, and then, just for the fact that it will improve your, finding a better job opportunity, I don't think that's necessarily true. It's a much more, from my perspective, it's a much more complex process to choose, a candidate out of a pool of candidates, and it's not only about what degree they have and whether it's a master's or a PhD. So I wouldn't, and then from this other perspective is actually the same. If I were to decide whether I want to pursue a PhD program or not, presumably just based on the fact that whether that will improve my job opportunity, I wouldn't look at it that way. Again, finding your next job or your first job, that's also a complex process that, for one thing, I would say, it could be about your family and about, the location of the opportunities that you have. And these are all personal because it happens to me. I had 2 academic job opportunities as well as 3 industry job opportunities at the same time. And I just picked the one that was in the city that my wife also had a job or had a PhD. So it's I would say it's complex. I think over time the difference between having a PhD or having a master's, over time that difference is going to be washed away. So early on, maybe the trajectories to get to your career goal, long-term career goal, might be different, but those are going to converge over time. So I wouldn't worry too much about it. It's like, I would say it's, naively, it's very similar to say you're very smart, you're in 2nd grade, but, your qualities is a 4th grade. Should I skip 3rd grade or not? And, it doesn't matter. It puts you a year ahead, but I think at the end, you're going to be the same person and your same skills.
Ward?
Yeah, I guess I should start the answer with, I don't know if the overall, let me put it this way. I think that the question sort of gets at, is there going to be more competition for a job if you are a master's or if you have a PhD? And I don't know the answer to that. I suspect the real difference between having a master's and having a PhD is, as Bonham was saying, it's more about your initial trajectory and what sorts of jobs you're initially going to be open to. I suspect that people who have PhDs are going to be more selected for jobs that require creativity, and it's going to be assumed that you can sort of move around and sort of gain the skills that you need. Whereas if you're a master's, I think that, at least this would be the case in NVIDIA, we're going to assume more that you have a set of skills, and we're going to hire you for a job that is specifically for a given set of skills, that we're not assuming that you're necessarily going to grow beyond. But later on, after you've established yourself in your career, again, getting back to our earlier topics about networking, again, that's all about networking. And networking really helps you get your foot in the door as well as having a PhD for the creativity jobs requiring creativity. And the reason that networking helps you is because people can say, I know this person, and I know this person is good at what he or she does. And so, if you have a job that requires that, I can recommend that person to you.
Yeah, can I just jump in and add one other thing, which I think might be relevant to some of the questions that I saw come up earlier in some of the panels, and that's really around the exact environment we're in today and thinking about moving into a PhD. So I actually graduated college in 2008, and although the economy hadn't quite collapsed yet, the clouds were very much on the horizon, and hiring had definitely already slowed down. And so for me, having the ability to go into a fully funded PhD program for 5 to 6 years was actually a really good deal, personally, to kind of take myself out of the job market for a while and kind of hope that things had improved on the other end. And that ended up working out really well. That's not going to be a blanket statement for everyone. I don't think everyone should go to grad school because the economy, it's hard to find a job right now. And I think the difference between taking out loans and getting a master's and doing that versus looking into a PhD program where I was, even though the economy was not great, the program was fully funded and guaranteed to be so, definitely gave me a lot more flexibility and gave me a lot, kind of some relief from jumping into the job market at the time that a lot of others were doing so. So in some ways, I didn't have the most pure intentions when I went in to get a PhD, which probably is one of the reasons that I've also moved beyond the strict scientific research within my career. And, if I had, people who had jobs throughout that whole time, and they made a lot more money in those 5 or 6 years than I did on my little PhD stipend. So it's not necessarily just about the money, but if you are looking at, considering right now, do I go to grad school? Do I get a master's? Do I get a PhD? Do I look for a job? It definitely it is worth taking a look at the broader economy right now and having that at least come into play a little bit.
So one question that we discussed earlier, but I'd like to revisit now, is the role of discussing your intentions to pursue an industry career path with your advisor while you're getting your PhD. In engineering, it's not as unheard of for an engineering PhD student to pursue an industry career path. But I know in the sciences, it can be a little less common. So we'll start with Benom, since I know his advisor, and I know his advisor is super supportive of industry career paths, so we'll start off on a positive note.
Well, yes and no. So I was a student number 5 that was graduating from our, in the PhD program. And at the time, our PhD group and the team that we were in under that advisor that you and I both know, and I love and respect, was very biased towards an academic career.
So I'm wrong.
Out of the previous 4, actually I was number 6, so there was 5. There's 5 of them, but one of those 5 graduated after. So the other 4 who graduated before me, they all went to academia. So they're all very successful professors like yourself, Andrea, different universities in the U.S. So I was under a lot of pressure, and that's why I also strongly considered, applied, interviewed, and actually got 2 job offers in the industry. In the academia. But at the same time, naturally, I had that conversation with my advisor, and I couldn't trust his opinion at the time as much because he was young, and he had only gone through an academic path himself, except for an internship program that he's done at one company, one industry. And to my surprise, I couldn't trust beforehand, but to my surprise, when we had that conversation, he was actually extremely supportive of that. And I remember one thing that I clearly remember is when we were in one of those conferences that I was mentioning earlier, and we were in his hotel room, and he was advising me in his hotel room what career path to choose. And he told me, Behnam, you should not go to academia. So and that's why I will love him forever, because I think even though your advisor might be young, or they have seen more things than you have. They've had a lot more interactions, and I give them a lot of, especially now or in the past 5 years, I give them a lot of credit because they're not really researchers. And I experienced that when I was a research scholar myself and an OPI at USC, and I saw what these poor professors go through. They're extremely talented scientists and engineering researchers, but at the same time, they're really running a very small business. They're running a group that is not only about teaching or doing research or helping their PhD students do their own research programs, but it's also really about running that group, finding different sources of money, making sure the lab is running, and that experience actually was very helpful to my advisor to tell me, hey, forget about academia. You are built to be a CEO, and that's what I pursued, and I'm forever grateful for him for that.
So, Ward?
Yeah, so I was thinking about that. I was lucky that my advisor was always supportive of, has always been supportive the whole time I've known him, of me going back and forth between academia and industry at the various times when it seemed appropriate for me to do that. And I would say that, like, for me, the only downside was I thought as a grad student that, like, my advisor knew what it was like to be in industry, and he didn't really, because, like, many of the people who are successful in R1s have always been on an academic path, right? And so they know that path really well. They know it inside and out. But unless you are an advisor, unless your lab has a lot of interface with industry, then it's kind of hard to know exactly what's going on there. And to be able to give your students a sort of a good feeling or overview, or, you know, give them good people to talk to. So I'd say that, like, for me, the question has not been whether or not to discuss those sorts of things with your advisor, because I think your advisor should know, like, what you're thinking about and where you're going, and that puts your advisor in a good position to try to help you as best your advisor can. But you should also know that you should get a lot of other opinions, right? Just like with anything in your life, you should, you know, sorry to keep on saying network, but it turns out, like, my answer is here, you should network, right? And you should find out, like, and I heard earlier somebody was talking about networking, and they said, you know, I went and talked to so-and-so, and at the end of that conversation, my last question was always, so whom else should I talk to about this? Like, that should always be your last question, right? And I feel like I should put in, since networking sometimes gets a bad rap, right? The point of networking is not to be slimy and schmoozy. The point of networking is to find out, to meet people, and to sort of, to learn things from them, but also to be in a position where you can potentially help other people in the future, right? That you should think of this as getting to know people whom you might be able to help and who might be able to help you and who are good people. And if you think that somebody in your network is not a good person, you should drop them from your network. So I say, like, yeah, you should discuss this with your advisor, I would say. It's always been good in my experience. And if your advisor is not supportive of that, maybe you need a new advisor, right? That's sort of what I would say.
Yeah, so one of the pieces of advice that I received when I first was looking to join a lab at Caltech was I should look at the ratio of students who were going into academia versus industry. And I think that that's great advice for anybody looking for which lab to join, because that does give you a little bit of an insight into how they're going to be thinking about sending people into industry. I'd say I was similarly lucky in that my advisor had a long track record of sending people both into postdocs and eventually academia, as well as going into industry. But at the same time, the culture of the graduate program that I was in, I'd say really looked down upon that, and it was kind of talked about just amongst the students, and not necessarily, it was not from the faculty, but just the kind of student culture was that those who had what it takes, who could make it, were going to go into academia. And if you couldn't make it in academia, then, okay, maybe you'd be considering industry. And I think that that was a really hard mindset to kind of break out of. And one of the things that I've done continually since is to tell people who are in PhD programs and struggling with what to do next is, you know, industry is not a failure, right? There's no, it's not that, well, there's pinnacle academic jobs are the only thing that are going to make you happy and everyone else is settling for a job in industry. Many of us are very, very happy being in industry, and it was the right path. So something that I always say is that, you know, there is a bureaucracy and politics in every setting of the world. We're very different, right? The academic bureaucracy and politics are different from what you get in a very large company. They're different from what you get in the venture capital world. But it's not like one of them is perfect and one of them is terrible. And so I think it's worth being willing to kind of say, regardless of what my peers think, regardless of what my advisor thinks, if I've done the research and know that this is the right path for me, to go ahead and pursue that path and know that it's a really good choice for you and that you're going to probably be successful and happy. And know that there are many people who switch back and forth, right? There are 2 people on this panel who have said, at this point in my life, this is what's working for me. At a different point in my life, I want to pursue something else. And so I don't really think that, having your advisor, hopefully your advisor is very supportive. If they're not, I would say, find a co-advisor, find a different advisor, find other people to talk to who have made this leap. And again, use that network. And, as you're talking to these people, to kind of say, okay, well, my advisor is not extremely supportive. What's your best advice for how I can make this work? Are there ways that you can help me understand what I need to do to get into industry? Most advisors are not going to keep you there forever and not let you leave because you have an industry job lined up. At the end of the day, you do need to fight for what you want. But I think that it's more and more common that because the academic market is so saturated, that people realize that there are lots of other good career paths out there. So hopefully you won't come across that, but if you do, keep fighting for what you want to do and don't let the culture or the individual tell you that only one path is the right one.
So one question, and I'm going to slightly expand on the question, is how can I do a PhD in quantum computing if I have no experience in it whatsoever? So, kind of expanding this a little bit is, how can I do a PhD in, X topic if all of my previous research is in Y topic? So if you think about undergrad research, it very rarely lines up directly with what you do in your PhD. I'm going to assume that for the 3 of you, it did not line up directly. I know for me, it did not. Okay. So if for all of you, it did, then I will talk. But I'm gonna go in reverse order this time and start with Taylor. Please tell me it did not line up directly.
No, it did not line up directly. So yeah, I would say that at least when I got to graduate school, there was a fair bit of flexibility in terms of choosing a lab. So many of us had already had conversations with specific professors as we went through the interview process and got accepted to schools. But we had until our second quarter to really join a lab, and then there was always the chance to change the lab. And at least at Caltech, when I was there, we didn't even have to stay in the same department. If we wanted to find another lab that was willing to accept us in engineering or biochemistry or whatever, that was fine. And so I definitely made a change in focus. I did my undergraduate research in a little bit more organic chemistry, and then I did my PhD research in organometallic, which I know has some similar words, but the actual research itself was quite different. And so I think that there are probably some basic skills that you need to have in many areas of focus. And so if you don't have those, like if you're going into a programming, if you want to join a lab that does programming and you've never done programming before, you're probably going to need to have some conversations with that advisor about what skills you need to build up before you're at the level that you are willing or able to join that lab and start contributing. And I think the same goes as you move on outside of your PhD into whatever roles are next. It's not impossible to change what you're doing research in industry or for your postdoc or whatever else is next. But it definitely takes a little bit more effort if you want to make a larger leap than a smaller leap. And so I think you need to be willing to talk to people and understand and know that you might have to take 2 steps, right? 2 smaller steps in order to say, okay, well, I really want to get into research in this area, but there's an intermediate step that fits a little closer with what I'm doing. I can get half the skills that I need for the new step and then maybe transition into that later. So hopefully that answers the question a little bit.
Oh, that was a great job. Behnam, what are your thoughts, if you have any additional?
So I would add a few things. First of all, mine didn't also line up directly, but I would say that is natural. Because if you're starting a PhD program, you're going to contribute, to sciences and engineering, something that's new, that's something that nobody has ever done before. So it's natural that you have to invent new things and come up with new things. Now, that said, if you're talking about you're switching fields and you're going to a new field and you don't know nothing about it, first of all, you have to make sure that you have make a right choice. If you don't know nothing about that field, let's say quantum computing, for example. I don't know anything about quantum computing right now. So I would say first, I want to make sure that I do go through an education period myself, not necessarily a PhD program, before choosing that PhD program, to make sure it is really a new field that I want to go and do and learn about and do research. So assuming that, for instance, the person who asked the question has already done that and knows some basic understanding of what is quantum computing, so knows some of the fundamentals, I would actually encourage, that would be the most fun you will have, plus probably you will have the most creative outputs and outcomes. Because I had this experience, especially among my during my PhD program among my other friends. We all had the saying: if you don't know much or don't know anything about that field, you will be naive, which means you don't know what cannot be done. So you're going to go and do it. So from a research perspective, it will actually be, I would say, kind of an advantage to have if you don't know what cannot be done and go and try to do it yourself. That will result in really good research publications and outcomes for that topic.
Ward?
Yeah, so it's interesting. I like the two previous answers. And I think I could just add a little bit on the top and just say that my transition from undergrad to grad, the research was very different. I was doing, as an undergrad, I was doing quantum limited noise studies in semiconductor diode lasers. And as a grad student, I was doing nanoscale self-assembly, right? And then in my first job, I was doing holography, right? So these transitions to me seem like completely natural. So I think one of the things that helps in physics is that in the physics education, it is assumed that what undergraduates have is the basic underlying canon, and that grad schools are supposed to train you on what you need to do the next thing. And so I think that was just assumed that you would most likely be doing something in grad school that was not what you did as an undergrad. And I think that sort of assumption is what allows me to then switch fields when I switch jobs.
Maybe I will add quickly to that. So what I said earlier about the PhD program, it's knowledge and process. And if you don't have the knowledge whatsoever, just the process of going through gaining that knowledge, for instance, gaining quantum computing, that by itself is going to be the value. I do acknowledge if you don't know anything about it, probably similar to what Taylor said earlier, you probably have to spend some extra time, and your PhD is going to take maybe a year longer to educate yourself, take some courses on computing or programming or quantum computing or programming. But, that's exactly the point of the PhD program, to learn the process in addition to the knowledge.
So before we wrap up, I want to give everyone an opportunity to make a concluding statement or remark in case there's something that we haven't had a chance to talk about today that you really want to convey to all of our student listeners and our future student listeners, since this will be posted online. So I'll let Ward go first.
Oh.
I know, yeah. It's always hard being the first person because everybody else says great things that you wish you had said.
Right. So I think I'll go back to the thing I said first, right? Which is the thing to really do is figure out what kind of work you'd like to do, and figure out if you're in a position to do that work. And your question about when you're trying to figure out whether or not you're in a position to do that work, instead of thinking, oh, I have already done research in quantum computing, therefore I'm in a good position to do research in quantum computing. You know, quantum computing, it turns out, is more up in the air than you might think at the moment, right? So what you should be looking for is transferable skills at each time you're making a transition. It's like, even though I'm not doing exactly this job, right, the skills I've learned from doing these programming tasks that I've done in the past are transferable, say, to quantum computing. Or the skills I've done in building equipment is also transferable to whatever you'd like to do. And what will be important is that you are able to convey that you can do those things, right? That you can, even though you haven't had exactly that experience, you can still do them, and that you can communicate those results, or the results of your work, clearly. So I would say, yeah, concentrate on your transferable skills and your ability to communicate effectively.
Great. Benom?
So I would go back to, I was looking at the list of questions earlier and go back to the theme that keeps coming back. Should I do a PhD or not? And should I pursue industry career versus an academic career? So I just wanted to share my own decision-making process, if you call it that, because it's not really a convex optimization problem. It's a leap of faith kind of a problem at the end of the day. But it's very personal. It has a lot of at micro scale, individual scale, it had a lot of parameters for me. As I mentioned, some of them earlier, like for instance, family. What are the other opportunities that you have in front of you? In each of those opportunities, what kind of people you're going to be interacting with. For me personally, that's extremely important. That goes back as a subset of that networking. I learned early in life that the people around you, like your first degree and maybe second degree people in your network, those are the ones that are going to be very impactful in your growth, generally in life, but especially in your career. So choosing that path based on those people, that was an important set of parameters for me. And right now, my best friends that are from a professional life, they all come from actually my first job. I still in contact with them after 15 years or 20 years, and they're really very dear to me. On a macro scale, also, there are a lot of parameters, and especially in these times, as Taylor mentioned, what are first of all, even if we didn't have a pandemic at hand and, the economy was all good, what are the macro trends? With you, for instance, what's going to happen 5 years from now? That's when you're done with your PhD and now you want to go for a job. What is hot right now? Is it going to be hot then? So consider those and look at the macro scale of what is going to happen in 5 years from now. For me, essentially a lot of parameters in life on a macro scale are also important. What do you want to do with your life? And I mean, very simply, where do you want to live? I had an opportunity to go and live in a small state, small town for an academic job. And, I remember very clearly, they set me up with a real estate agent. They put me, in touch with the family to go and meet, to talk about how is it to live in this community, which was a smaller community, a smaller town. And that was enough for me to, decide, no, this is not for me. It's a wonderful town, but it's not for me. And this, even though they may sound simple, these things will impact your trajectory of life early on, trajectory of your career early on. So I had to consider all of these, and it's a complex process, so it's not a yes-no question or certain optimization problem.
So Taylor?
Yeah, I would definitely echo the last point that Benom made. I mean, my career choices have definitely had a lot of influence from where I wanted to live and, who else was around, and, wanting to be close to family, wanting to balance a career with a spouse. And, all of those are really valid choices. And, every stage of your life when you're making these decisions, there's going to be more that comes into play than just, exactly what you wanted to do intellectually. But to the original question at hand, I guess I would just come back to say, there's really no way to sugarcoat that how difficult a PhD is, right? It's a hard thing to do. It is spending several years of your life throwing yourself at some of the hardest problems that may or may not actually have an answer, right? No one picks a PhD project or has an advisor say, why don't you work on this, because they know exactly what the answer is, right? It may or may not work, and you're spending day in, day out throwing yourselves at these problems kind of on faith that you have what it takes to make a breakthrough, or that you can pivot it into something that is valuable and provides learning to the community. And so, doing a PhD is not necessarily something that I think anyone is or should be doing just because they think it sounds cool, right? You have to have that drive. You have to have the love of the chase of the question. You have to have the, desire to pursue a field and push it beyond where it is today. But I think that once you're there, once you're doing that, once you've found a way to be successful in that, really there's no wrong choice of what to do next. And the skills that you learn through that process, the kind of tenacity that you find within yourself to push through, the ways that you find to kind of support yourself emotionally during these times and get through hard times and find a way through them is going to serve you in a career in academia. It's going to serve you in a career in industry. And I know that many people that I work with say, well, we're not working on something that I don't need a PhD in my field to be doing the work that I'm doing. But people love working with people who have PhDs because they have this ability to push through and to ask hard questions and to be really honest about what the data is saying. And so I think that, regardless of where you go, having this background is going to serve you really well.
Okay. Thank you. Thank all three of you very much for giving, a little over an hour of your time, and some of you have been with us all day. I really appreciate it. You gave a really unique perspective that I can't get from my faculty colleagues. So I hope you have a good afternoon or evening for some of you, and thank you for joining us.
Thank you for having us, Andrea. Great job. Thanks.
Sure.
So it's now 1:20, which means that we've officially kind of sloshed into our next session, which is essentially just a wrap-up and answering any questions that have come up that we didn't quite answer because maybe they were asked during the sessions previously. So to run through this, I'm just going to deep dive into all of these. So starting at the top, is it possible to do an internship with an advisor that you're interested in to get a feel for how well you would work together before committing to a 4 to 6 year relationship with this person? And the answer to that is yes. So that internship is actually kind of the point of summer REUs. And summer, like when you're an undergrad, you can do a summer research experience with a faculty member. And I've had a couple summer REU students that I've accepted into my group. Actually, one of them is a first-year PhD student this year. However, unfortunately, just as several people have brought up, unfortunately this year, due to COVID, pretty much all of the REUs have been canceled. So this year is a very unfortunate time for actually getting that type of summer internship or internship experience. So I do not have a solution for you, but for younger students, I would encourage them to apply for REU positions. They can, it's usually an 8 to 10 week experience with faculty members. Many schools have either REU sites or entire, 2-3 semester internships. So as an international student, how do you decide which universities to choose? Should you have more than one advisor in mind when applying? So this question is actually, as an international student, as a U.S. student, just as a student in general, right? How do you decide which universities, which schools, And should you have more than one advisor in mind, you should definitely have more than one advisor in mind. So what I tell my students is that every school you apply to, you should have at least 3 potential advisors in mind. And this gets to the point of, maybe you start in one advisor's group, you decide you're not happy in that group and you want to change. So, you at least want to have one, backup plan, right? You always want to have what's known as a risk mitigation strategy, right? You always want to have a backup plan in place. And that's where, the other 2 advisors come in. And so from my personal experience, I actually had to change advisors 3 times. So I actually needed 4 potential advisors. And that's because 2 of my advisors left my school. 1 didn't get tenure. And so I needed a 4th advisor. So 3 actually wasn't enough. So you need at least 3. And how do you, choose schools? So one strategy is to first figure out what areas of research you're interested in. And this may seem incredibly challenging, like Professor Shaw mentioned. He was interested in multiple areas of research, right? Not just one super narrow field. Or I mentioned, he thought he was interested in one thing, and then it turned out he actually wasn't interested in that. He was interested in something else. But I usually, advise my undergrads that, a good place to start is to at least figure out, are they interested in theory or experiment? Because that will at least knock out 50% of the faculty, which is a big start. And then start reading faculty web pages, right? And if you start reading a web page and you find yourself skimming it because you're really bored, then that probably means you're not interested in that topic. But if you find yourself, reading it and actually going and Googling words to find out what they mean and then going back and reading more, and then maybe, you start ending up on like a rabbit hole of web pages, finding out more and more and more, then you're probably interested in that topic. And then you can start, asking your faculty members, maybe asking PhD students, like, who are the faculty members that work in this area? So don't feel like you have to find faculty members all by yourself, on Friday nights in your dorm room. Right? Ask your faculty members, ask research advisors, ask PhD students. Right? So current PhD students, they were at some other school for undergrad, right? Like, they came from somewhere. They didn't just appear out of thin air, right? Like, they're great resources. But don't overlook your TAs, right? Like, you can use them as resources other than just your homework sets. So continuing. Okay, how many universities can I apply to since I would be asking so many recommendation letters from each professor? Could it exceed 10 given the situation this year? First, it should exceed 10. And once a faculty member writes 1 letter, asking them to write more is really just asking them to modify it, right? So, dear selection committee, I strongly recommend, insert student's name, for admission to insert school, right? So all I'm doing when after I've written that first letter, all I'm doing is changing that insert school, which is a one sentence modification, right? Like, that entire letter, that will take me, an hour or more to write. For the N+1, submission, it is trivial. It is really easy to change that. So if you only ask me for 1 letter, if anything, I'm kind of annoyed because I invested all of this time into writing this beautiful letter that now only 2 faculty members are going to read. I want to send it everywhere so that everybody reads it and everybody finds out how great you are. I don't want to just send it to one place. That's kind of disappointing for me. So ask me to send it to a lot of places. Don't just send it one place. Please ask for a lot of places. And on that note, if you're eligible, everybody who's a senior undergrad should apply for the NSF and the NDSEG Fellowship. So the NSF, the National Science Foundation Fellowship, you can apply for once as a senior undergrad and once either your first or your second year in grad school. So you can only apply for it once when you're in grad school. So your senior year undergrad, it's a freebie, right? So if you apply for it and you don't get it, it doesn't count towards your once first year or once second year in grad school. But you can't apply for it both first year and second year in grad school if you don't apply for it your senior year, right? So take that freebie, right? Like, apply for it, get feedback on your application, get information on like where you were weak, where you were strong, and also don't think about it as, like, oh, my application's not going to be as strong as a first-year PhD student, right? The people reviewing this know you're a senior undergrad. They don't compare you to a second-year PhD student, right? It's a sliding scale. So if anything, it's easier to get it when you're a senior undergrad than it is when you're a second-year PhD student. So you should apply when you're a senior undergrad because that's going to be your easiest time to get it. So do that, right? Like, I realize you have a lot of stuff going on senior year. It's super crazy, but the application doesn't change. It's the same every year. You could start writing your application over the summer, early. Although I realize faculty members can also start doing things early, and we never do. Okay. So, let's see. Continuing down on the questions I can answer. Hold on, I have 2 dogs. What was the balance of coursework and research like during your first year? So this varies greatly by school. So some schools will have like full course load first year with very minimal time for research, and some schools will have almost like a 50-50 balance. And if it's like a 50-50 balance, then that really means that the coursework is spread out over 2 years. So this is really a school and almost department-specific question. So it's not really, there isn't a fixed answer to that. So I think those are all of the questions. However, Joe and I did want to briefly retouch on one point. So I might actually, since Joe's still on here, I might let Joe answer the question about the variations in post PhD and postdoc variations, because Montana State actually does something really unique that USC doesn't do. So I wanted to give him a chance to actually talk about that.
Thank you, Andrea. It's been really fun to sit here, and I've been doing some work in the background, but listening to all the panelists has been really great. What a wonderful, rich array of expertise all you students have been exposed to. I think it's a wonderful thing. What Andrea's alluding to is a message that I sent her about something that we do. It came up earlier about postdocs being really only a useful avenue if you are going into academia. We actually do something a little bit different, and I guess you could call it a postdoc, you could call it a staff position or whatever, but we hire a lot of times one of our recent PhD graduates into a postdoc position as a way of launching a new company. So they think that they want to go in and start a company, and we will hire them as a postdoc and put them to work on some project. And I mean, the funding has to come from somewhere, so they're working on that project 100%. And meanwhile, they're writing proposals for some kind of small business innovative research or small business technology transfer kind of proposal. And if they start winning proposals, then they change from 100% at the university to 50% at the university, 50% at the company, or maybe 90 at the university, 10% at the company. And then they slowly ramp up their company until pretty soon they don't work at the university anymore, and they work only in the company. We've launched several of our most successful companies around us that way. So I thought that was kind of an interesting thing that some of you might benefit from hearing about. Thank you for that opportunity.
Of course, it's an approach that we don't have at USC, but it has to do with the nuances of overhead and fringe and all kinds of administrative things. So there were actually 2 questions I missed I wanted to touch on. So one's from Diana. So how strict is recommended coursework for going into a different discipline, for example, a chemical engineering undergrad who doesn't have quite enough chemistry coursework for most chemistry PhD programs? And there are similar questions, like we've had physics undergrads go into material science or electrical engineering, and etc. So I would say the most important thing in those types of situations to remember is that, on day one of your PhD program, you're going to start off taking grad level coursework in that PhD program. So there's a reason why it's recommended coursework, because you're going to immediately start off on the grad level version of whatever that coursework is. So it depends on, what the exact coursework is. So if it's something like thermodynamics and maybe you've had the chemi version of it and maybe it was called something slightly different, then you might be okay. If it's something like inorganic chemistry and you've never had any inorganic chemistry, then this might be an example where maybe you want to go to a community college and just take, an inorganic chemistry class so that you don't get completely blindsided, right? Because your screening exam is going to be related to your coursework, and you don't want to do poorly on your screening exam just because you, didn't take a class to have the appropriate foundational knowledge. I would say it's recommended because the school wants you to succeed. There is flexibility, right? They aren't going to kick you out. But it's recommended so that you have the appropriate undergrad foundational coursework so that you succeed in the graduate level coursework so that you can then pass the subsequent exams so that you can do your research. And then the last question I wanted to answer is, what advice would you give to someone applying to a PhD program who eventually wants to work their way up in academia, for example, a dean, associate dean, etc.? And really the first step in doing that is you have to become a faculty member, right? So if you're thinking you want to go on the dean, associate dean, etc. path, what that basically means is that you want to become a faculty member because that's the first step in doing any kind of administrative path. And after you become a faculty member, and then after that, after you get tenured, and then after you become a full professor, usually, then you can start working up. At some departments, you can become department chair as an associate professor, and that is usually if you're going to become an associate dean or dean, being a department chair is an intermediate step. At some schools, you can skip that step. But, really the first step is become a faculty member and get tenured. And then after that, at whatever school, let your dean or associate dean know that that is actually a career path you're interested in, and ask for mentoring in it. Ask to be put on committees that will give you appropriate mentoring, like research committee or compliance committee or things like that. But that's more like the 15-year out view. Really, step one is get an academic career position. So if there are no other questions, I'm going to close this out. I would like to thank everybody for joining us, especially all the panelists who really made this possible and who agreed to do this in February before everyone knew they'd be working from home. So thank you, and I hope everyone has a good afternoon.